Welcome. Thank you for joining us here today. And my name is Bettina Bassermann. I'm part of the Solution Architects team here in the DACH region. And together with my dear colleague Jörg Bunse, we will be talking about open source business for the next 45 minutes. And hopefully we will be able to answer any questions you may have after this session. So, here's the agenda. First, we will describe different types of open source software licenses. Then we will talk about the business model. We will hear about benefits of open source, what it brings in comparison to proprietary software. And at the end, we explain how upstream projects actually become a SUSE product or, in general, a commercial product. Okay. So let's start, and actually every story has a beginning, and I'd like to give you a little bit of an introduction how it all started. So today, no one in the technology world can deny that open source software is here to stay, but how did it all start? And historically, it actually started with Unix and Bell Labs. In 1925, Bell Labs was a research and development subsidiary of AT&T. And AT&T, the telephone company, was such a dominant company that as a result of an antitrust case, it was bound by the US Department of Justice consent decree prohibiting it from engaging in commercial activities outside the field of telephone service. And consequently, when Bell Labs created a general purpose operating system called Unix, the decree prohibited AT&T from exploiting Unix as a commercial product. Bell Labs was a non-profit organization, so Bell Labs gave Unix away in source code form under terms that allowed modification and redistribution. So, kind of like the motto from Sting, if you love something, set it free. You know, we're talking with songs all the time in these presentations here, so I think that was a fit. So when the antitrust decree was lifted, AT&T started granting restricted licenses for Unix, which resulted in replications of Unix. So the source code was compiled for specific processors from IBM, HP, Sun, and so forth. And that actually led to a lack of interoperability, which consequently created frustrations. And that resulted in the free software movement, which at the end led to a project called GNU. And GNU stands for GNU is not Unix, and had the goal to provide a replacement for Unix operating system. And in the late 1980s, Unix popularity was fading with the start of the new microprocessor or microcomputer architectures like Apple or DOS or something. And as mentioned, operating systems are particular to the processors, and the Unix could not easily be adopted to these new platforms. Unix, however, had a standard specification called POSIX, that was very popular, so various people wanted to create an operating system that was compatible with POSIX, but free of license limitations. And one of the persons was a student called Linus Torvald. And Torvald actually released the first version of Linux in 1991 and made it freely available, which was a major change in the world of technology. Okay, so there's actually this myth that open source software is just free software that anyone can use however they want. And that's actually not true. There's several different types of open source licenses and even source available licenses properties that seem to be very similar, but actually are very different when it comes to what you're allowed to do with it. Oh, by the way, the term free software refers here to freedom, not to price. So they say it's libre, not gratis, so it is free, but it's not free of cost or charge in that sense. And therefore, open source, this open source world is a world where freedom is paramount, and some practices in the open source community are discouraged, but not by an authoritative order, but by the consensus of the community, and we'll come to this later. So, while proprietary software is the copyright property of an individual or a company that limits its use, distribution, and modification by way of a proprietary license. On the other hand, open source software is distributed with its source code, and it lets users freely inspect, modify, and enhance it per the license agreement. And these are the two ends of the spectrum, but there's another license type that became very popular in the recent years, and that's the source available software licenses. And source available licenses are deployed like open source licenses, and people have a tendency to mistakenly refer to them as open source, but they're not. This is because source available licenses put restrictions on the use of the software, while open source licenses do not. And source available licenses share some qualities with open source and with the proprietary license. But there are differences, there are important differences between them, so let's sort this out. So, about open source licenses. The fundamental concept of open source is that it allows the software to be freely used for any purpose. So, open source grants all the rights of copyright, and it doesn't impose any restrictions on the use of the software. And this means no license restrictions, no field restrictions, no market restrictions, no territory restrictions, and so forth. I think you get the picture. It can, however, impose conditions. And lots of people get confused about the difference between conditions and restrictions. So a condition is, if you do this thing, you have to do the other thing. So for instance, if you decide, I want to drive a car, then you have to have a driver's license first. And open source licenses place a range of conditions on the use of licensed code. So for instance, copyleft licenses like the GPL impose significant conditions like source code sharing, while permissive licenses impose hardly any at all. And generally, these are the two categories of open source licenses, the permissive and the copyleft. So copyleft, like for instance GPL, which require derivatives of the software to be licensed under the same terms, and permissive licenses like MIT, for instance, which allow the software to be reused in any project, even in closed source project. But we will, in this presentation, focus on the copyleft licenses here. However, if you're interested in a list of permissive licenses, you can look this up at www.blueorgcouncil.org. And copyleft is here described on the slide. However, there are different flavors from ultra strong to weak. So GPL, there's Eclipse, there's MPL, there's CDDL. We're not going to go into the details here. But I think what you should remember is, these three things that copyleft says: if you make binaries available, you must make the source code for these binaries available as well. And the second part is the source code must be available under the term copyright terms under which you got your code. And the third point is you must place, or you cannot place, additional restrictions on the exercise of the license. These are the three parts that you should remember. Now, talking about proprietary licenses, in contrast, proprietary licenses do impose restrictions and limitations. So, for example, there can be limitations on the number of servers or the number of users for a license. So if you're licensed, for instance, 100 users, but you have 200 people using the software, then those extra users are not licensed, and you're actually violating the license, and you potentially engage in a copyright infringement. by exceeding the license restrictions. Other types of proprietary license restrictions may include that you can only use software for testing purposes or with specific projects or products. So there may be bundling requirements, means you can't use the software in a standalone mode. Okay, and then between those different parts, there's the source available license. So to recap, they are like, source available are like make the source code available. So like open source, these licenses are deployed in a frictionless manner, meaning that you're not clicking anything to accept anything. But unlike open source, and more so like proprietary terms, they actually have license restrictions. So to sum it up, I guess my message is there are many different types of licenses available, and some look very much alike. However, make sure you know if your license has a restriction or a condition like GPL, so you're not violating any license terms. But the idea is, in the open source community, with the community, to inspect, modify, and enhance a project freely to make it fit for purpose, of course. And the benefit lies in the possibility to use it without a restriction, but, for example, for GPL, with the condition to share the source code again after you have done some enhancement. And moreover, there is an ecosystem of companies that created services around open source software, and we will talk about this later when we come to the business model of open source software. Okay. So there are actually commercial dependencies of open source. So the type of licenses you choose has implications on what you can do with it. We've learned this already. And in business, it also has implications if your company or parts of your company are actually sold to another company, which happens quite often, I guess, in our industry. And one thing you need to know is that the direct licensing model of open source means that your open source licenses don't need to be transferred, because the right do not flow from one recipient to the next, but through the terms, to all recipients in the first place. So there's no transfer. So as long as you're not violating the license, you can always exercise your own license to the code, regardless if the distributor, who you received it from has actually acted compliant or not. And I think that's definitely a benefit for open source in this industry. Proprietary licenses, in contrast, must be transferred from one license owner to the next, which can be a challenge in mergers and acquisitions. And another benefit, I think, is that GPL, for instance, has no governing law. It is internationalized, so they did this to prevent its forking into national versions. So the drafters of GPL actually placed harmonization with local law above the certainty of defining a governing law. So accordingly, background law will dictate which state or which country will be used to interpret the GPL in a particular instance. And then two more points maybe. Open source communities drive innovation, and therefore they tend to attract top talent to those companies embracing open source technology. And then due to, let's say, a magnitude larger than a usual development department, communities drive innovation, and that usually results in very short release cycles of the respective project, and we'll learn about that. For some it's good, for others may not be so good. Okay, now let's talk about the business model of open source. It's actually a myth that only students in their garage or dormitories develop open source software. We did have a problem here in this industry because you need highly skilled individuals and developers that contribute to innovators' project. These developers want to earn their keep, they want to earn money, and therefore you need to find a way to monetize the value they're creating. And open source software can also be commercialized for instance, selling services, trainings, technical support, or even consulting, rather than the software itself. And selling subscription for online accounts or even server access to customers. And this is all a way of adding value to the open source software. And offering training programs and certification courses, as we also have here with the SUSE certification program, is another benefit and a way to commercialize things. Then there's the multi-licensing, or also known as open core licensing. And in the dual or multi-licensing model, the vendor develops a software and offers it under an open source license, but also under a separate proprietary license term. So again, we're coming to these middle types. And the proprietary version then can be licensed to finance the continuous development of the free open source version. The use of open core licenses has become popular recently, especially with startups. However, it's rather controversially or even considered unethical in the open source community, because the underlying objective is that the business model is to harness the size and the international scope of the open source community at once, but as I said, it's largely bigger than a regular enterprise development, but but they use this to achieve a sustainable commercial venture. Then maybe one other aspect is the risk of open source, but I think we come to this in the next slide. So, advantages of open source. With open source, you have a choice between multiple vendors of the same or similar solution, thinking about Ceph, OpenStack, Kubernetes distributions, and all of that. So the results bring you several commercial advantages. One is, for instance, you have a better position to negotiate pricing due to the broader competition. You can do investment protection, as you do not rely on one vendor. So if one vendor, for example, drops a product or changes their behavior, like, for instance, Red Hat with CentOS, you have options to continue and do not stuck in the same fashion as you would with a proprietary product from, let's say, a Microsoft or Oracle. And also, due to the ability to move to a different vendor with the same project-based product, like for instance an OpenStack, you can keep your internal know-how investment of training of your employees and so forth. And the last one is probably open standards that are used in the open source enable you more flexibility, and we come to flexibility here. But I think I need to speed up. So flexibility means that, you can access the source code, so you can do it yourself or leverage any external company or buy a service here. Imagine you would try the same with a proprietary vendor that you'd like Microsoft, for instance, change the GUI of SQL according to your needs. The answer would probably be no. And another benefit is you can always try to buy before you actually invest in it. So all of these things, speed is another thing. I think we talked about this through to the collaboration of so many different vendors. Innovations happen much faster. And also, like for instance, the Linux project, we're working currently with 13,500 developers. So large open source projects create massive communities and an ecosystem around these projects, which create also many add-ons and huge knowledge base in the industry. And moreover, certain vendors bring very unique know-how from different backgrounds. For instance, Volkswagen is part of Cloud Foundry, Mercedes is part of Kubernetes, CERN is part of the Ceph program. So enterprises can drive innovation much faster, and you benefit from the collaboration here. Security is the last one, and I only have to mention it because it comes in your part later on as well.
Does it?
Open source software has often been described as more secure, than proprietary software due to the source code transparency and the sheer amount of eyeballs, basically, from the community checking the code. And for larger projects with a vivid community, I would actually second that statement. However, it is not a guarantee, as we saw with the XZ backdoor issue. So looking into security certificates like SALSA or common criteria for supply chain, with your open source distributor, or using implementation guides for hardening, like DISA or FIPS, increases your security level with any vendor. So now we talked about the advantages of OSS, and we need to talk about risk using upstream projects, because I said you can do it yourself. But what does it take? What does it cost? What happens when something breaks? And why, what when you lose parts of your developer staff? How do you protect your investment? So there are thousands of projects, and you need to select the ones that suit your business case. That's one of the the hard things. And you need to handle the complexity to build your own solution out of the little, many projects that are out there, and stitch them together. Then you need to test it to make sure it all works together. And you certainly need to have developers create the glue that makes the puzzle pieces a real solution. And then you need to consider, where the solution, should be used, and if this requires, for instance, industry-specific certification to be compliant. So the benefit of having choice can result in a hard-to-maintain project after all, but there's help. There's an entire industry that helps you with all sorts of offerings to benefit from open source, but it means that choices, what gets packaged and tested together, might not be in your hands. My colleague Jörg Bunse will now explain to you how projects become a product, for example, in a Linux distribution or SUSE manager, to give you a glimpse how much knowledge, effort, vision, and hard work is required to build a product and keep it alive and constantly improve it to the changing market conditions while maintaining it for those that need long life cycles. So thank you for your attention, and over to you.
Yep, thanks a lot, Bettina. Okay, good. So, does it work? Yes, it does. Oh, too fast. Yeah. So after Bettina set the stage for the basics, so the legal foundation and all the other stuff, let's go to some real-world examples. And well, as we are on SUSECon, these examples may probably come from SUSE, but it's not SUSE only. Yeah, as I said, let's go to some real-life examples. We heard a lot about open source projects, but a project is not a product. In reality, many projects make a product. And I will give you some examples for that. And well, first and foremost, we have to maybe to learn, but I'm pretty sure all of you in the audience, it's not that much. You know these terms already, right? They have their own vocabulary, their own terms, and if we want to speak about projects, about open source, first of all, we need to know what is a project in general, and a project could be virtually anything, right? From a simple library, so it's not even a standalone program, right? It's just a set of routines that could be used by other applications, up to, well, complex applications, maybe a word processor or something like that, right? It could be virtually anything, from small to big. And then, and this is special for open source, is the term fork. So it's pretty often that you have a project, someone finds your project useful, but he or she doesn't like the direction it goes in, or maybe there's something missing. And then you have the chance to fork the project. You take the existing project and create, let's say, like in a tree, right? You have a second thing with well, things that you consider to be important. So you take the existing one, modify it, and so you create your own project. Then we have a maintainer. Well, that's pretty simple. Maintainers are the people that create the software. Most of the time programmers, developers. And then we have two things like upstreams and downstreams. These reflect the software changes, patches. An upstream, if I send something upstream, I'm delivering, maybe I developed a patch for something, I send it to the maintainer said, yeah, okay, that's very useful, I will keep it in the project, and it will become part of the project. And we have the second thing, like downstream, which are software changes sent to the maintainer of a fork. And the last thing, and that is very common in, let's say, in Linux distributions like SUSE Linux Enterprise Server. We have backports, right? So we take let's say, an existing component, and then we notice that this component might be vulnerable, right? And then we keep this component, but we fix the problem. Yeah, and this is something that's quite often in let's say, in these enterprise distributions, right? That's the backport. It's not a new version, where I fixed and I added something. It's still the same version, but I fixed the problem, so we are safe then. Okay, so I promised to give you some examples. So first and foremost, Linux as the operating system is a very prominent example, and you mentioned it as the killer app. That was the term on your slide before, right? But Linux is not Linux. I read in an article the other day that there are approximately 280 different Linux distributions. I think there are much more than that, but maybe 280 notable Linux distributions. And why do we have so many different Linux distributions? Well, it's an operating system, and if you take a look at Windows, one size fits all, which is a general purpose operating system. That's different in open source. As I said before, like forking projects, there are different people have let's say, a different target user, a different target audience in mind, or different target purpose. Maybe I need a very flexible, small operating system because I want to do some measurements with machine, or I want to machine steering and things like that. So the requirements are totally different from, let's say, a desktop operating system, right? And that's why those distributions are different. Yeah, and all of the time they change components. What we see here are components of a Linux operating system, of a Linux distribution, but they are projects as well. So maybe someone finds it very useful to use Nginx as a web server, and someone else says, no, I need a full-blown Apache web server. Yeah, so we just exchange this component, or maybe the graphical user interface. Yeah. So we want to change that to GNOME, right? Or OpenOffice. No, I don't like OpenOffice. My target audience is for LibreOffice, right? Or Cockpit. And now we come to SUSE Linux. Yeah, we want to use Yast as the, let's say, configuration tool, right? So there are quite a lot of target users in mind, and that's the reason why we have so many different Linux distributions. When talking about a Linux distribution, consists of many different components, which are projects. See, we have, just as an example, this is from the SUSE Customer Center, just the number, how many packages. It's not that many projects that are inside of SUSE Linux Enterprise Server, but just to give you an idea about how many different packages we have in the current 15SP5, it's almost 60,000 different packages. Yeah, and this 60,000 packages, they build the SUSE Linux Enterprise Server. Yeah, and well, some of them are very small, some of them are bigger, right? And as I said, many large and small products, they build a Linux distribution. Another example, when talking about SUSE products coming from a project to a product, that is SUSE Manager. Again, this is just a subset of different open source projects that build the SUSE Manager, right? As we see, the Spacewalk, Kiwi, Salt, PostgreSQL database, and for monitoring Prometheus and Grafana and so on. All this kind of stuff. And I think you mentioned it before. I think that was the slide with a large euro symbol. Build your own. Yes, of course. You could go, and because of the licensing terms, you can pick the software of any of these projects and say, okay, I will build my own SUSE Manager, right? All the functionality is there, yeah? So, and I need different projects for different functions, so setting up new systems, right, will be done by Cobbler if I want to deploy new systems to bare metal. Yeah, and for the monitoring, I have Prometheus and Grafana and so on. So all of these products can be used standalone, right? But you don't want to have, let's say, in this case, what is it? It's 4 by 4, so 16 different standalone applications. So if you want to perform your task as an administrator, that might become pretty complicated. So, most of these projects, they have interfaces to interact with other pieces of software, but these are dozens of different interfaces, right? And in addition to that, all these projects, they have their own release cycles, right? So one is updated, let's say, every month, the other one every 6 months, and one is updated once a year. And that's the advantage of having something like SUSE, right? Who creates from all these different standalone project one product. We create the glue between the different projects, and we support and maintain the whole stuff. And that's important because of the dozens of different release cycles. We schedule combined updates, right? We will update SUSE Manager. Yeah, and we will provide update for, let's say, the whole product. And, even more important, we revalidate. Does it still work, right? So once a single component has been updated, maybe it doesn't work with the other components anymore because the developer changed the interface, right? So we make sure it still works after doing an update. So coming back to the operating system, and coming back to different target audiences. SUSE, at the end of the day, we have 3 different flavors of SUSE operating system. Yeah? So one is the SUSE Linux Enterprise Server, which is the enterprise, it's in its name, the enterprise version of the operating system. It comes with support, it comes with maintenance, and so on. And then we have 2 additional distributions with OpenSUSE Tumbleweed and OpenSUSE Leap, which are the community versions of it. And all 3 Linux distributions, or let's say flavors, have different target users in mind. Maybe let's start with Tumbleweed, which is totally different. This is a rolling distribution, so we have updates all the time, yeah? All the time, there is no release cycle. That's different from OpenSUSE Leap and SUSE Linux Enterprise Server, which is service pack oriented, right? So apart from, let's say, bug fixes and fixing vulnerabilities with patches, we have fixed dates for service pack, right? And then we will put the operating system onto another level, right? From Service Pack 4 to Service Pack 5 and so on. And that's different from Tumbleweed, so that's the reason why there is no release number behind it. And you could see, I put 2 examples to it. From the kernel version, that OpenSUSE Tumbleweed is far ahead, right? From the number, it's really far ahead. While OpenSUSE Leap and the SUSE Linux Enterprise Server are pretty close together, especially the glibc version number. Yeah, it's still the same, and that's well, That's good and bad at a time. You mentioned the XZ backdoor, right? That everyone of us heard about during the last month. And this is the cutting edge rolling update. That's the reason why Tumbleweed had that backdoor. Because it's always the latest update. And once this guy placed the backdoor in that library, Tumbleweed had that backdoor. And that's different from OpenSUSE Leap and SUSE Linux Enterprise Server. Because they are more conservative, right? They didn't have the problem. They were not involved by this kind of problem, right? And so what's the reason? Why do they do that? Why do they have a Tumbleweed, a Leap, and a SUSE Linux Enterprise Server? Well, as I said before, they aim for different things. OpenSUSE Tumbleweed drives innovation. Yeah, innovation, that's first and foremost. This is the goal for OpenSUSE Tumbleweed. When I put that check mark into brackets, I said, well, it's not the goal to drive stability in that case. Well, and that's, yes, they do as a general effort, but that's not really part of the game. They really want to be cutting edge, new technology, new components, and so on, right? And it don't drive security as well, right? This is more, let's say, the playground. It's the playground for the other two distributions, right? OpenSUSE Leap, that's not innovation, but stability and security. And then comes SUSE Linux Enterprise, which is even more focused on stability and security. But there are certain things, and well, you are part of it, where we drive innovation, because let's take the whole area of the SAP HANA technology, with the different hooks and resource agents and so on. There's nothing that, well, a Tumbleweed developer would do something, because they don't, in general, they don't care about SAP HANA databases. Maybe how the latest graphics interface card with the latest driver should work, right? That's my bad. So SUSE Linux Enterprise Server drives innovation as well in certain areas, yeah, enterprise-related areas. So that's totally different audience. So as a conclusion, because maybe I should have said this before, because in the title of the presentation today is how subscription payments drive innovation. The developers of OpenSUSE Tumbleweed and OpenSUSE Leap, most of them, they're doing it for free. Some of them are SUSE employees, right? But even if they do it for free, they had to put so much effort in it that it's related to certain payments. It's maybe to infrastructure, to servers and so on. And that's why SUSE as a company supports the community of OpenSUSE, right? With money, with resources, with development resources, with people as well, right? So I think that closes the circle. That's why subscription payment really drives the innovation that maybe comes with Tumbleweed. Because it's only possible because SUSE received the payment from paying customers with subscriptions, right? Okay, and that's why what you said before, open source is free, but not free of charge, right? And maybe you want, because that was part of your things with copyleft and permissive, maybe you want to say something about that?
No, I guess this is the conclusion again. I think we want to summarize this, and so these are the things that we want you to take away. That, you know, remember, if you want to do it yourself, yes, it's free, but it's not free of charge if you want to do it yourself. And if you want to go to a commercial distribution, then you have your subscriptions. And copyleft and permissive are the different types that we had, and also, I think a benefit that we mentioned was that it is easier to transfer with M&A, like mergers and acquisitions, which happen a lot in the IT industry. Then things like the community drives innovation, obviously, and that open source attracts talents. These are all things that we want you to take away from this presentation, and more so that, as Jörg just explained, that SUSE provides financial, technical, and development support for the community, and that with your subscription payment, you keep this cycle of development and innovation alive. So it's not just that you get a support case or support ticket and you go to somebody in the support organization to get it fixed, but all the benefits that we just talked about in the last 45 minutes actually need to be financed through your subscription payments, and we just wanted to make sure that what are the dependencies here and what are the benefits for you. Okay.
Exactly.
I think we're actually in time, so if there's any question, we're happy to answer them.
That's good.
We must be very clear with what we did. So then I guess thank you very much for your attention and for coming here. We were standing in front of you in the party, so thanks so much, and enjoy the rest of your day and the evening. Thank you.